So let's look at this question 2. We're given an object which is released from a point X above the ground as shown in the diagram, and it travels the last 30 meters, which is from B to C, in 1.5 seconds before hitting the ground. So ignore the effect of air friction. All right, so before we can answer this question, we have an object which is released. So when you release an object, you don't apply any force to it, then it means that we know that the initial velocity of the ball at point X is 0 meters per second. So when you release the ball or when you're dropping the ball, their initial velocity is 0 meters per second. So we know the initial velocity of this ball at point X. All right. So the first question says, what type of motion can you describe, or name the type of motion described above? So we know that the type of motion, you can say it's a free fall. You can write free fall because we know that the object only experiences gravitational force on this motion, or you can say it's vertical projectile motion or projectile motion. All right. So the second one, which is 2.2, they say calculate the magnitude of the velocity of the object at point B. They want the magnitude of what? Of the velocity here. We want the velocity of the ball at this point. We want V at point B. All right. But we don't have much information, because we know that from when we check from X to B, we know the initial velocity is 0 meters per second, but at point P we don't know the velocity which we're looking for. We don't know how long it took the ball from X to B, and then we also don't know the displacement on this path, right? But we can consider the path from B to C. From B to C. All right. If we check this path of B to C, our initial velocity, which is at B, because the ball now it's dropping, it's going down. So our V initial, which is the velocity at B, we don't know. And then our V final, which is the velocity at this point when it hits the ground, we don't know it yet. Please don't say the final velocity here is 0, because the velocity, the final velocity, which is at 0, it's a point whereby it reaches the maximum height and then it changes direction. But in this case, the ball is just falling down. We can't say the velocity at B is 0. We can't say the velocity at C is 0. All right. But we know that our change in displacement is equals to 30 meters. All right. And then we were also given a time that it takes 1.5 seconds for it to travel from B to C. So our time here, our time is 1.5 seconds. All right. And then we know that our gravitational acceleration is 9.8 meters per second squared. All right. So in this case, we have to take a direction. So to make things simple, we can take direction going downward to be positive. So any motion going downward will be positive. So it means our gravitational acceleration is positive. Our displacement will be positive. Our V initial and our V final should be positive, because the motion of the ball throughout this motion, yes, it's going downward. So any motion going downward should be positive. All right. So now we are looking for the initial velocity. All right, we are looking for the initial velocity, or the velocity at B, all right, which is our initial velocity when looking at the path from B to C. So our initial velocity in this case, we don't need the final velocity because we don't know it. All right, so we can remove this because we don't need it. We are looking for the initial velocity. So we can check our formulas here. The first formula, we don't have the initial and the final velocity, which won't work, right? Because it's like we're having two unknowns. Even the second one, we have v final and v initial, then which won't work. Now we are looking at the third equation. We have the change in displacement, which we have it, our initial velocity, the one that we're looking for, we have time, and then we also have our gravitational acceleration. So it means that the third equation is the one that is going to work best for this problem, because if you can check the last equation, we have v initial and v final, which it's two unknowns, and we can't work with that for now. So it means we're going to take the third equation, which says change in y is equals to v initial multiplied by change in t plus 1 over 2 multiplied by our gravitational acceleration change in time squared. All right, so we can substitute our change in y, or your displacement is 30 meters, which is equals to, we are looking for the initial velocity, then our time is 1,5 seconds, then plus half of our gravitational acceleration, which is positive 9,8, then we multiply that by 1,5 seconds, and then we square that time there. Then we're going to have 30, which is equals to 1,5 multiplied by the initial velocity, plus when you punch your calculator here, you will get your answer to be 11,025. And then now when you do your math, you're going to take this 11.025 to the other side. Then we're going to have 30 minus this value here, which is equals to 1.5 v initial. Then we can divide both sides by 1.5. And then now our initial velocity, or v initial, now becomes 12.65 meters per second. Then we can see that we got a positive answer. Why? Because the velocity here at B, it's going, the ball is still going downward. So it means that our answer is very much correct. See, so this is our magnitude and the direction of this, all right, of this velocity at point B. All right, so the second one says calculate the height of point X above the ground. They want to know the height of this the height of point X above the ground. All right, so we know the velocity at B. We know that the velocity at B, we know that it's 12.65 meters per second. So if we consider the path xb, if that is 2.2, that is 2.2 or 2.3, that is 2.3. If we consider the path from x to b, all right, we know that the initial velocity at x, our v initial is equals to 0 meters per second. Then the final velocity at b, we know that it's 12.65 meters per second. All right, so here, in order for us to find the height, we must find the displacement, or the displacement or the distance between B and X, and then we can add it to this one, and then we know the height at X. All right, so now we know the initial velocity and the final velocity, but we don't have the time it took for the ball from X to B. All right, and then we are looking exactly for our displacement. Right, then our gravitational acceleration is 9,8 positive 9,8 meters per second squared. So we don't necessarily need the time, right? So we are looking for the displacement, so that we can be able to add the displacement from path xb to the path bx, and then we will know the height of this point here above the ground. All right, so we have this information. We have the initial velocity and the final velocity. We are looking for the displacement. All right, so from our formulas, we have v initial and v final. All right, we don't have time, so the first formula goes away, and then the third formula won't work, obviously, because we don't have time. Even this one, we don't have time, so the relevant one is the second one. Right, so we have v final squared, which is equals to v initial squared plus 2 multiplied by the gravitational acceleration multiplied by the change in displacement. So we're going to have 12.65 squared, which is equals to 0 squared, because our initial was 0, right, plus 2 into 9,8 meters per second squared multiplied by change in y. Then when you get your calculator, you get that this gives you 160.0225, which is equals to 19,6 multiplied by our change in y. We divide both sides by 19,6, divide both sides by 19,6. Then now our change in displacement is 8.16 or 61 meters. All right, so the distance or the displacement between X and B, we know that it's 8,16 meters. So they want the height of point X above the ground. So you can see that for us to get the height, all right, so the height, in order for us to calculate the height, we have to add the height from, or the displacement of xb plus bx. So it means our height for that point X there, we have to add the two displacements here. And as you can see, when they want the height, they want the distance from X to C. All right, so our height in this case, it's the same as we want the displacement from X to C. And then we know that we can add the distance from X to B plus B to C. All right, you can see it here. Let me remove these things because we no longer need them. So in order for us to get this height here, we have to add this displacement plus this displacement. It will make one straight line, which will know the height of X there. So we know that xb, the displacement between X and B, it was given to be 30, and then the displacement that we calculated here was the displacement from X to B, from X to B, BC, 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 BC is 13, then that one is 8 point something. So it means I mixed them here, but it's fine. So it means here we're going to have 8.61, all right, So now our displacement will be 38.16 meters. So this is the height of point X above the ground, right? So I hope it makes sense. I hope you do understand what I was trying to do here, and I hope this video provides you with insight of what we do in this vertical projectile motion. And thank you for your time, guys. Hope to see you in the next one. Bye bye.